Series and parallel circuits. What are the differences and how do they work? Well, we're going to do another visual demonstration to show just that. Before I start, I will say, if you don't have a full understanding of Ohm's law, it may be an idea to go back and watch my first video in this series to ensure that you can fully follow and understand this demonstration. I have two circuits set up here. The top circuit is the series circuit and the bottom circuit is the parallel circuit. And you can already see there are visual differences between the two, but we'll first start off with the series circuit. A series circuit simply means there is just one path for the electrons to flow and one path that all of the components in the circuit are connected to. So all of the electrons are actually coming from this power supply, flowing through one path with all of these LEDs connected on the same path. That is what makes a parallel circuit. All of these LEDs here are connected in one line, so the electrons have to flow through one LED to get to the next LED and the next LED. In a parallel circuit, it works differently. You can see the electrons here are moving faster. That's because there is more current flow, and I will get to that shortly. The electrons come from the power supply, but then as soon as they get to the LEDs, something different happens. Some of the electrons pass through the first LED connected across the circuit here, because if we ignore the rest of those LEDs at the moment, we can see what happens here. The electrons can flow from the power source and pass through this LED and go back to the positive side of the power source. And then with the other LEDs that are all connected in parallel, some of that current coming from the power source does go through this one, but also passes through this LED and back again. And some of it passes through this LED and back again. And same for the last LED. So you can see the electrons here in the parallel circuit are moving a lot faster than the electrons moving through the LEDs, because the current, which is represented by the speed of the electrons here, the current is being shared between all four of these LEDs. So the movement of all the electrons through these LEDs here equates to the current coming from and returning to the power source. So that's why the current moving through the LEDs looks slower, because the current coming from the power source is being shared between all four LEDs. And this is not the same in a series circuit. Now, because they're in a series circuit here, for each of the LEDs, they have their own resistance in the circuit. To overcome that resistance, going back to Ohm's law, you actually need to increase the voltage to allow the current to flow through the circuit. So these LEDs each have a specific resistance, and because each of these LEDs requires 3 volts to light, if I actually adjust the power supply here to 3 volts, you'll see that not enough current is flowing through the circuit here. Just nanoamps of current are flowing. It's not enough to light the LEDs. We need to increase the voltage to overcome the resistance in this series circuit. Now, because each LED requires 3 volts each, in a series circuit we actually have to increase the voltage to supply 3 volts to each LED, meaning that we have to give it 9 volts. If I increase the power supply to 9 volts, you can see that the power to the LEDs is restored and 20 milliamps is flowing through the entire circuit. This means that I am now supplying 3 volts to each of these LEDs. And I can actually test this with a voltmeter. So I've just put a voltmeter across one LED. And you can see here we've actually measured 3 volts across this one LED. Each LED has 3 volts across it. So in a series circuit, the voltage has to be increased to overcome the resistance of all the components in that one series path. If we go to have a look at the parallel circuit, a parallel circuit is powered completely differently from a series circuit. You can see that I actually have 4 LEDs in this circuit, but they're only being powered off of 3 volts, completely the opposite of the series circuit. And that's simply because there are multiple paths that the current can flow through, which means unlike the series circuit, there is no additional resistance to overcome because we've allowed the electrons to flow through multiple paths. You could also say that we've put more lanes on the freeway to allow traffic to move faster. So in a parallel circuit, all of these LEDs are actually being fed with 3 volts from our power supply. That's all we require from this power supply is 3 volts. The difference is more current is consumed in the circuit, and we can visually see more current being consumed because the electrons here are flowing faster and the flow of current is split between all of these LEDs, so there are more lanes for more current to flow through. So if I wanted to power these 4 LEDs in a series circuit, I would have to give them 3 volts each, which would equate to 12 volts. But because they're in parallel, I can power all of those LEDs just from 3 volts, but they now require more current. So in the real world, I'll have to make sure that my power supply can provide this current. And for 80 milliamps, pretty much any type of power supply battery will supply that with no problem. So what's happening is, instead of these LEDs demanding more voltage to light, they are demanding more current because because each of these LEDs requires 20 milliamps. 20 milliamps flows through here, 20 milliamps flows through there, and this one and that one. And the total of that is 80 milliamps. As we can see on the side here, the total current flowing through this parallel circuit is 80 milliamps at 3 volts. Now I've removed one of the LEDs from the parallel circuit so that we can have a look and see that each of these circuits are consuming exactly the same amount of power. If you want to understand more about calculating power, look at my previous video about calculating power. Now just to show that this series circuit that requires 9 volts is consuming the same amount of power as this parallel circuit consuming 3 volts, I'm going to do a quick calculation. As you may have learned from the previous video, P equals IV. The power in the series circuit is equal to 9 volts times 20 milliamps. And for the parallel circuit here, we're powering it from 3 volts, but it's consuming 60 milliamps. So let's do that calculation again. 3 volts times 0.06 or 60 milliamps is giving us 180 milliwatts or 0.18 watts, exactly the same as the series circuit. I understand that this may be a little bit more difficult to get your head around than previous videos, and they will start to get a little bit more complex as we go into the more advanced electronics theory, but the best way to learn is to experience it on a practical level. If you do have questions, or if you feel that I missed something out from this video, please let me know, leave comments, and I'll try to do my best to explain it in more detail. If you do like these videos, and if you do enjoy learning about electronics, do subscribe to this channel. There are plenty more videos to come. My plans are to continue making videos like this, not just these visual every circuit videos, but also practical demonstrations as well. So definitely subscribe to Simply Electronics for more videos in the future.